Hello everyone. I would like to welcome you to our NanoSensors product screencast. Today I'm talking about AFM tips enabling atomic resolution imaging, AFM probes for dynamic AFM with sub-nanometer amplitudes. NanoSensors develops and manufactures tips for scanning probe microscopy. My name is Oliver Krause. The struggle for the highest resolution achievable with scanning probe microscopy is motivating us to create a new type of AFM cantilever. In the big graph you see a Lennard-Jones potential of two bodies as a function of their distance. When an AFM tip is operating in standard acoustic or tapping mode, the tip is oscillating with an amplitude of some 10 nanometer. Therefore, when operating with that large amplitudes, the tip is interacting predominantly with many atoms at the same time via long-range forces. The closer the AFM tip is getting to the surface, the smaller the number of atoms interacting will be, and we will be able to resolve maximum spatial resolution. The major problem when operating a cantilever extremely close to a surface, like indicated by the orange part of the interaction curve, is that the strong short-range forces will bend the cantilever, and due to the very narrow operation distance, a standard cantilever would be attracted that strongly by the surface that the tip will get in contact. This is called snap to contact or jump to contact. The cantilever has to withstand an approximate force of about 200 nanonewton, an empirical value which was determined by Franz Giesibel. If we assume an amplitude of 5 angstroms, the force constant of the cantilever has to be larger than 300 Newton per meter. In this graph, the minimum amplitude to avoid a snap to contact is plotted against the cantilever stiffness or force constant. The black line, which separates the red from the green area, should symbolize that cantilever operations that can withstand the 200 nanonewtons necessary to avoid a snap to contact. In the graph, there are two areas marked, which should represent standard force modulation and tapping mode cantilever force constant. For those cantilevers, the amplitude has to be larger than 20 to 80 nanometer for the FM types and larger than 5 nanometer for NCH types to be in a stable operation regime. If we would like to operate with an amplitude of 5 angstroms or less, we have to move to the lower right corner of the graph. We would need about 300 newtons per meter cantilever for stable 5 angstrom amplitude scanning and about 2000 newton per meter for an 1 angstrom operation. So, how do we get such a high force constant cantilever? If we take a look to the formula plotted here, how the stiffness of a cantilever could basically be calculated, we will see that either the cantilever length has to be reduced or the thickness of the cantilever has to be increased. If you take a look on the scanning electron microscope images on this slide, you can see that we increased massively the thickness. On the left side, you can see a standard tapping mode cantilever with a thickness of approximate 4 micrometer, and on the right side, a 10 micron thick, ultra-stiff 1000 Newton per meter cantilever. Finally, we did create two types of cantilevers. Both are 100 microns long, with thicknesses of about 7 and 10 micrometers. Those cantilever dimensions will result in force constants of about 600 and 2000 newtons per meter respectively. So, how detailed is it possible to image with this cantilever? What resolution is possible with this tip? Here in this impressive image, which was taken by Professor Sugawara from Osaka University, you can see the atomic lattice of a nickel 001 surface. The bright spots represent the oxygen atoms, whereas the nickel atoms are located at the dark sides. This image was captured with a NanoSensors ultrastiff cantilever with an amplitude of 4 angstrom. I would like to thank you for your interest and your attention. You will find the NanoSensors Ultrastiff cantilevers in our special development list. You can download the list from nanosensors.com/pdf/special development list PDF. If you have any questions, want to give feedback or need more information, please get in touch and contact us at info@nanosensors.com.